Good morning, my dear friends. I hope you all are doing great. So today we'll be talking about an important hormone, which is basically a peptide hormone, okay, known as insulin. Okay. The questions related to the insulin are mainly asked in competitive exams. So let us start our topic for today. First of all, when we look at the hormone insulin, or we call it as a peptide hormone because there are amino acids in it. And how many amino acids it contains? Last time I told you, okay, it contains 51 amino acids. Usually a protein should have n value greater than 100, but in this case the n value is here. The n value means number of amino acids are just 51. Okay, n stands for number of amino acids. So how many amino acids are there? Only 51 amino acids are here. Correct. But it's an exceptional case. I told you last time. It is considered as protein. It's an exceptional case. Okay, so even though n value is here less than 100, okay, for a protein, for any protein, if you look, n value should be greater than 100. Please remember this thing for a protein. But I told you that this insulin is an exceptional case. Even though the n value is less than 100, how much is n value here? 51. Okay, it is still considered as protein. Still considered as protein. Please remember this exceptional case. So insulin is an exceptional case with us. Okay. Now this insulin is basically made up of two chains. Okay. Before that, let us explain what is this insulin. It's a peptide hormone. It contains basically 51 amino acids which are linked to each other through peptide bonds. So it's a peptide hormone produced by beta cells of pancreatic islets. So the beta cells of pancreas does produce, okay, or do produce insulin. Okay, so insulin is produced by the islets of Langerhans. Okay, so once again I am telling you, the beta cells of pancreatic islets will produce the insulin. Correct. Let us discuss first about the structure of an insulin here. So let's have a look. It consists of two chains are here. Okay. So insulin contains two chains. The chain A and chain B. Correct. Chain A, this contains 21 amino acids. So chain A will have 21 amino acids and chain B will have 30 amino acids. So please make note of this. So chain A will have actually 21 amino acids and chain B will have 30 amino acids. Correct? So let us have a look here. Let us suppose this is the chain A. So how many amino acids are here? Let us consider this as an amino acid here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. So 21 amino acids are here in the chain A. Let's consider it as chain A. In chain B, what we have? We will have basically the 30 amino acids. So here we have a chain B here. It will have 30 amino acids. So let me draw the chain B here. So let us see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 30, okay, 30 we have. So chain A will have 21 amino acids. And this will have, chain B will have 30 amino acids, 30 amino acids. Okay, this is our chain B. Correct. Now what is there? Let us see here. Let's count it. This is first amino acid, second, third, fourth, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now what is important here, have a look please. This sixth amino acid, the sixth one, this sixth amino acid is basically CYS. You know what is CYS? This is sixth amino acid. The CYS is nothing but cysteine. It is cysteine here. Okay? And the 11th one here is cysteine amino acid. So it is cysteine. So we have the 11th one and 6th one. Between cysteine, the 6th one and 11th one, there is a SS bond. SS bond stands for disulfide bond is there. Correct? So there is a disulfide bond. In the same way, this 7th one, if you look at the 7th one here, okay, this is 7th one. This 7th one is also cysteine. 7th one is also cysteine, CYS. Let me tell you that CYS is your cysteine amino acid. Okay? And here also the 7th one in this second chain is also cysteine, CYS, the 7th one. So between this and this also there is a disulfide bond. Have a look. There is a disulfide bond between this and this. So in this chain A, there is a disulfide bond between 6th and 11th amino acid. 6th amino acid is cysteine and 11th is also cysteine. Between chain A and chain B, there is a disulfide bond. Like look here, sulfur is a disulfide bond between cysteine and cysteine, the 7th and 7th amino acid. 7th amino acid of chain A with the 7th amino acid of chain B. Please make note of this and we will go further. We will discuss about, there is one more disulfide bond here. On this particular structure, 20th is basically the cysteine here. Cysteine amino acid of chain A, the 20th amino acid, cysteine, okay, does make a bond with the 19th. Let's take it as 20th and 21. Okay, 20 and 21. So this is 19th. So let us consider it as cysteine. So this is 19th. So my dear friends, there is a disulfide bond between 20th amino acid, which is a cysteine amino acid of chain A, with the 19th amino acid, which is the cysteine of chain B. Okay, so this is my chain B and this is your chain A. So now there you will find out 3 types of disulfide bonds are there. If we consider them, have a look here please. This is basically the SS bond called as disulfide bond. This is a disulfide bond. Disulfide bond, correct? But you know that this disulfide bond is between 6th and 11th amino acid. 6th and 11th amino acid of chain A. So this disulfide bond is present within the same polypeptide chain. So this chain A is nothing but it's your polypeptide chain. Polypeptide chain. So when any disulfide bond, SS bond, is present within the same polypeptide chain, it is called as intradisulfide bond. You can also call it as intrapolypeptide disulfide bond. So this bond is nothing but it is your intrapolypeptide. Why? Because this SS bond, which is a disulfide bond, it is present basically in the same chain, like chain A. And chain A is nothing but a polypeptide chain. So between 6th amino acid with the 11th amino acid, there is a disulfide bond, but that bond is within the same chain. So it's called as intrapolypeptide disulfide bond. But when we look at this bond here, and we look at this bond is present between 2 polypeptide chains, chain A and chain B, between 7 and 7 amino acid. 7th cysteine amino acid and 7th here also cysteine amino acid. Here 20th is the cysteine amino acid with the 19th amino acid, that is also the cysteine in chain B. So my dear friends, these 2 bonds will be considered as interpolypeptide disulfide bonds. Disulfide bonds. So this one and this one, they will be considered as interpolypeptide disulfide bonds. I hope my dear friends you have understood. So now let us look here. For competitive exams, if you are preparing, I must tell you one thing here, that is, you will have now intrapolypeptide disulfide bond. Okay, and this will exist in chain A. It only exists in chain A. Okay, between cysteine. Okay, 6th amino acid we call it as cysteine and cysteine. That's no between 6th and 11th amino acids. And who are those amino acids? They are cysteine only, correct? Cysteine amino acids. But when we talk of interpolypeptide disulfide bonds, okay, they will exist between chain A and chain B. And these bonds are present between 7th and 7th of one chain and 7th amino acid of another chain. So I will write down here chain A and chain B. So here the 7th amino acid, which is a cysteine, it will make a disulfide bond with the 7th amino acid of another chain, that's also cysteine. So there is a disulfide bond. Okay. Then for chain A we will talk about 20th amino acid, that is also a cysteine, and here I am taking the 19th amino acid, that's a cysteine. So between them there is a disulfide bond. I hope you are understanding, my dear friends. So in competitive exams this question has come many a times, that if you look If somebody tells you that how many disulfide bonds are between two polypeptide chains, chain A and chain B. Between chain A and chain B we have interpolypeptide disulfide bonds. Their existence between chain A and chain B, these are only two. So interpolypeptide disulfide bonds are only two. Look here. But that intrapolypeptide disulfide bond is one. So my dear friends, if somebody asks you that how many intrapolypeptide disulfide bonds are in insulin, intra is only one, and that is between 6th and 11th amino acid of chain A. But if somebody asks you that how many interpolypeptide disulfide bonds are there in insulin, then you should tell that there are two interpolypeptide disulfide bonds between 7th and 7th amino acid of chain A and chain B, and between 20th and 19th of amino acid of chain A and chain B. So total disulfide bonds intra and inter will be 3. Intra is 1 and inter are 2. I hope you have understood that how these disulfide bonds are existing in an insulin molecule. Please make note of this. So my dear friends, now we'll be talking about what is the actual function of insulin in our body. Okay, so have a look here, the function of insulin. Insulin keeps the blood glucose within a normal range. So the level of glucose in our blood is maintained by the insulin hormone secreted by beta cells of pancreatic islets, correct? So the normal range of sugar in our blood is maintained by the hormone insulin, correct? So second thing, what does insulin do actually? It takes the glucose molecule to different cells or tissues. So the insulin molecule will be taking the glucose, okay, to the different tissues or different cells. And what do the cells do? Cells will, the cells then use this glucose. Cells are using the glucose for what? For energy, and store the excess. If there is an excess of a glucose, okay, that will be stored in the liver, like in the form of, glycogen. Glucose is stored in liver in the form of glycogen, or it can be stored in muscles, again in the form of glycogen, okay, or it can be also stored in the fat tissues. So my dear friends, the important role of insulin is to maintain the normal level of glucose in our blood, okay, and the insulin will take the glucose molecules, okay, to the different tissues or to the different cells, where the cells will use the glucose molecule for energy, and the excess of the glucose will be stored in the liver, muscles or fat tissues in the form of glycogen. I hope you have understood. Now there is a question. If the blood glucose level, okay, goes above the normal level of glucose in blood, okay, if the glucose in bloodstream, okay, becomes more than normal, or if the glucose in bloodstream becomes less than normal, then what will happen? Then the two conditions will arise. Okay, this question also comes in competitive exams. What is that? The conditions like hyperglycemia and hypoglycemia. What is this hyperglycemia and hypoglycemia? Let's understand. Okay, so we'll write down here. If blood glucose level becomes more than normal, then it is known as hyperglycemia condition. So this is your hyperglycemia. If the blood glucose level becomes more than normal. Okay. Second point, second condition, if blood glucose level becomes less than normal, okay, then it is known as hypoglycemia. Why does it happen? Why sometimes the blood glucose level becomes more than normal? Why it becomes more than normal? And why this hyperglycemia happens? The reason is simple. The glucose level in blood will become more than normal only when insulin is not functioning properly. Or you can say that when beta cells of pancreatic islets do not produce insulin. Or they may produce insulin, but that insulin will be defective. Okay? So, what is the reason behind hyperglycemia condition? The reason is very simple, that the production, beta cells do not produce insulin. That is one reason. And in another case, if blood glucose level becomes less than normal, if blood glucose is becoming less than normal, then what happens? Hypoglycemia. In this case, what is the reason? The reason is that the insulin may be produced, in large amount. Because of the large amount of, insulin production, what happens? Hypoglycemia condition can happen. So let us discuss these two things one by one. Hyperglycemia and hypoglycemia. It is due to either, we can say here, less production of insulin or no production of insulin or defective insulin. Here it will be the excessive production of insulin will cause this hypoglycemia condition. So let us understand them one by one. So my dear friends, now let us talk about these two conditions, hyperglycemia and hypoglycemia. Let's have a look. Hyperglycemia, blood glucose level is about 180 to 200 milligrams per deciliter. Okay, this is the range. And in case of hypoglycemia, where the blood sugar level will be very less than normal, okay, it will be below 70 milligrams per deciliter. So my dear friends, if the blood sugar level is less than 70 milligrams per deciliter, it becomes your hypoglycemia condition. Okay, and if it is above 180 to 200 milligrams per deciliter, it becomes your hyperglycemia condition. And what is the reason actually behind this hyperglycemia? The reason is very simple. Okay, you will study it in much detail in bio, but here I would like to give you the important things. The reason is that why hypoglycemia condition happens, like why the blood sugar level increases. Okay, the reason is that beta cells, okay, do not produce insulin. When insulin is not produced, then the blood sugar level will automatically increase, because nobody will take the sugar to the cells. So sugar level in the blood will increase because beta cells of pancreatic islets do not produce insulin. Okay, so beta cells do not produce insulin, correct? Or the beta cells may produce defective insulin, which is not functioning properly, or beta cells may produce less amount of insulin. So there may be beta cells may produce no insulin, or it may produce very less amount of insulin, or it may produce defective insulin, which is not functioning properly. So reason can be any. So beta cells do not produce insulin. Here, what will be the reason for this? Here the blood sugar level is going down only, and it will go down only when insulin is produced in large amount. So I will tell here, beta cells of pancreatic islets produce more insulin. So here more insulin production is here. Now, how can we cure it? Or what is the treatment? What is the treatment for this particular, hyperglycemia? How can we keep this hyperglycemia in check? Okay, so please remember this particular thing. Here, treatment is basically insulin production. Do not produce insulin. That means insulin in our blood is very less. So the treatment will be insulin injections. So a person who is suffering from hyperglycemia should take insulin injections. When somebody takes the insulin injections, the insulin will enter in the blood. Once insulin enters into the blood, it will decrease the high level of glucose in the blood. How? It will take the glucose to the different cells. So insulin injection is taken. After injection, what happens? This insulin will take this excess of glucose to the different cells. Okay? So the glucose level will be decreased or will come to the normal. Correct? Here in this case, blood glucose level is already very less. So beta cells of pancreatic islets produce more insulin. So already glucose level is very less. So you cannot take the insulin injection here. If you take insulin injection, what will happen? More insulin will increase and this will become further down. Glucose level will go further down. So what happens actually? In this particular case, what happens? You need to have meals at proper time. Meals should be taken at proper time. Meals should be taken at proper time. So when meals are taken at proper time, they will increase the glucose level. Or you can keep, glucose packets. You can carry the glucose packets with you, or you can have in some of the movies you have seen that, especially in one of the movies, that one heroine, she was, suffering from one actress was suffering from this particular condition. So what happened? She had a very low glucose level, in the blood. Then she takes one, chocolate. Okay, so that instantly that chocolate will provide glucose. Okay, and because of that glucose, what will happen? The glucose level in the blood will keep on increasing. Okay, so my dear friends, one question has come once in competitive exams, that was, why do diabetic people, so because these two conditions will happen in, these are two diabetic conditions basically. Why do a diabetic person carry a packet of glucose with him? Which patient will carry the packet of glucose? The patient who is suffering from hyperglycemia or hypoglycemia. The patient who is suffering from hypoglycemia will carry the packet of glucose. Okay? So my dear friends, because the blood sugar level in this patient will go down, will be below 70 mg per deciliter. Correct? So it has to carry, the glucose packets or chocolate, or it should carry, or it should have the meals on time, so that glucose level will go up or will reach to the normal at least. But in this case, you need not to carry the packets of glucose actually. Here in hyperglycemia condition, what is required? You have to take on the insulin injections, because already the blood sugar level is going very high. So when you take insulin injections, what will happen? Insulin will take the glucose to the different cells, so the level of glucose will come to the normal. I hope you will find out these two conditions basically in the people who are diabetic. So these are two diabetic conditions actually, hyperglycemia and hypoglycemia. I hope you have understood, my dear friends. Please make note of this. My dear friends, now we will be talking about skull cell anemia. Okay, so we'll be talking about skull cell anemia. What is this all about? If you take normal RBC, normal red blood cells, if you take, these are round in shape. Normal RBCs are round and flexible. Okay? In people with sickle cell anemia, those people who are suffering from this particular disease called as sickle cell anemia, hemoglobin, look at the hemoglobin here. It is a protein present in the plasma membrane of RBCs. So, those people who are suffering from sickle cell anemia, okay, the hemoglobin, what is hemoglobin? It's a protein present in the plasma membrane of RBCs, okay. So let me put it inside the brackets here, from here to here. This hemoglobin becomes defective. So with any person who is suffering from the sickle cell anemia, the hemoglobin becomes defective in those RBCs and causes the round RBCs. So it will make the round RBCs to become, so round RBCs will become skull shaped, or they will become like crescent moon shaped. So my dear friends, this sickle cell anemia is actually the defect related to the hemoglobin. And hemoglobin is basically a protein which is present in the plasma membrane of RBC. When this hemoglobin gets defected, okay, when it has some, defect in its structure, what happens actually? The round shape of RBC will change into skull shape, or it will change into the crescent moon shape. And this particular disease is known as sickle cell anemia. So let us understand it in this way. Let us suppose we have a RBC with us, and this is the plasma membrane of the RBC, let's suppose. Okay. So this is with me RBC, red blood cell. It has the plasma membrane. Let's consider this as a plasma membrane. And everybody knows that this plasma membrane is a lipid bilayer. So in common language, if I tell you, let us suppose we have here in plasma membrane, we have basically this particular protein, and this particular protein, let me call it as hemoglobin. So this protein is here, let me call it as hemoglobin. Okay. So this RBC is basically round in shape, and in plasma membrane of RBC we have basically a hemoglobin protein, this one. If this hemoglobin becomes defective, okay, if this hemoglobin, if it becomes defective, then what happens? Then this round shape of the RBC will change into the skull shape or crescent moon shape. So you will be having a shape like this here. If it becomes defective, who becomes defective? Hemoglobin. Then RBC will become skull shaped or crescent shaped, will become like crescent moon. So let us understand how it happens here. So my dear friends, this is your RBC now. I hope you are understanding. So this is your RBC, the shape of RBC. And let us think that we have basically the same hemoglobin will be here, but it will be just defective hemoglobin. Let's consider it as defective hemoglobin. And this shape is nothing but it's a crescent moon shape. Now what is the difference? This RBC, which was basically round in shape, the RBC which was round in shape, okay, it has a property. Can you focus here, sir? at this point in this area. This RBC I will take. When RBC was round, okay, at that time what happened? Okay, it can easily, okay, carry oxygen from lungs to various tissues through blood vessels. Correct? Because it's flexible. So this round shaped RBC, okay, it's flexible. It can easily carry oxygen from lungs to various tissues through blood vessels. But when the shape becomes like this, can you focus here, sir, now? When the shape becomes like this, have a look. Okay, crescent, moon shaped RBC, okay, it sticks to the blood vessel, stucks in blood vessel. So it will stuck in the blood vessel because the shape is not proper, it does not have a round shape. So when it does not have a round shape, it will not move properly in the blood vessel. So crescent moon shaped RBC stucks in blood vessels, okay, thus flow of oxygen from lungs, okay, to various tissues becomes slow or stops. Either it will become very slow, the movement of oxygen from lungs to various tissues, or it will stop. So my dear friends, when your RBC was in a good shape, okay, and it has a normal hemoglobin, okay, at that time what happens? It was easily carrying the oxygen from the lungs to the various parts of the tissues. But if you look at the crescent shape of the moon, it is not having the round shape, it is a crescent shape, it stucks within the blood vessels. So it's not able to carry the oxygen properly, or the rate at which the oxygen is being carried to the various tissues becomes either very slow or it stops. Okay, so my dear friends, I hope you have understood this particular thing. And this sickle cell anemia, it happens because of the defective hemoglobin. Hemoglobin, if it becomes defective. So due to defective hemoglobin, this disease comes into existence. Okay, and then these crescent moon shaped, RBCs, you can consider them as, dead RBCs now, because they are of no use at all. I hope you have understood, my dear friends. Please make note of this. So my dear friends, if we talk of the sickle cell anemia, what happens actually here? This particular disease is basically an inherited disorder. That means an offspring will receive defective genes from father and mother. So we call it as inherited disorder. That means an offspring will receive one defective gene from the father and one defective gene from the mother. Okay, so my dear friends, after that, let's go further and understand that if you have a normal hemoglobin, okay, it consists of 4 polypeptide chains. So your hemoglobin contains 4 polypeptide chains. Out of these 4 polypeptide chains, we have alpha 1, alpha 2, and we have beta 1 and beta 2. So these are the 4 polypeptide chains, or you can say subunits, present in the hemoglobin molecule. And even in this hemoglobin molecule you have porphyrin rings, okay, and even you have the iron also in hemoglobin molecule at the center. That iron will be in +2 oxidation state, iron. That's why it's called as hemoglobin. Heme stands for basically iron, and globin basically means protein part. If we take the beta globin from here, from normal hemoglobin is represented by HbA. That is the representation of normal hemoglobin. If we take the beta globin means basically beta chain, beta globin. If we take from this normal hemoglobin, beta globin basically means beta polypeptide chain. This I am talking about, beta polypeptide chain. If we take beta polypeptide chain, okay, what happens? This is made up of amino acids. Globin means protein part. So this is made up of amino acids. In this particular polypeptide chain, actually, let me mention here, it's a polypeptide chain. So if I take beta globin, means you have here beta 1 and beta 2. If we take a beta globin, what will happen? Actually, the 6th amino acid, which is glutamic acid, is replaced by valine amino acid. Okay, this causes defective hemoglobin, and which causes sickle cell anemia. So I will directly write down, this causes sickle cell anemia. So my dear friends, what I am doing here, I am taking basically the beta globin from the normal hemoglobin, and the 6th amino acid, which is glutamic acid, is replaced by valine amino acid, correct? And this causes sickle cell anemia. How the glutamic acid is replaced by valine amino acid? It's all because it's an inherited disorder. An inherited disorder, I told you here, defective genes are received by offspring from father and mother. And due to those defective genes, what happens? The glutamic acid is replaced by valine. Due to replacement of glutamic acid by valine, what happens? The sickle cell anemia is being caused. So this disease is being caused by this thing. So one thing you have to remember for your examination, that in case of a normal hemoglobin, okay, now the hemoglobin will be represented here as, after this mutation, the normal hemoglobin you have HbA, that is normal hemoglobin, okay. Now if you have now HbS, this is basically your defective hemoglobin, and this is normal hemoglobin, and it's all because of mutation which is happening, which causes the sickle cell anemia. So remember, because of the defective genes which offspring it is receiving from the parents, from father and mother, so because of those defective genes, okay, the beta globin from normal hemoglobin, what happens? The polypeptide chain of beta globin, the 6th amino acid of beta globin, that is glutamic acid is replaced by valine. This glutamic acid is replaced by valine only because of the defective genes and all. Okay, we will understand that the gene mutation, codons and all those things later, but you try to understand, because of this defective genes, glutamic acid is replaced by the valine amino acid here in this polypeptide, and it makes our hemoglobin defective. So this is the defective hemoglobin right out here. Please make note of this. So my dear friends, now we will be talking of the symptoms of sickle cell anemia, and we know that it's an inherited, genetic disorder basically, wherein the defective genes are received by an offspring from the parents. Okay, so what are the symptoms? A person who does have a sickle cell anemia will get the frequent, infections. Means that guy will be prone to the infections. So my dear friends, such guys will be prone to the infections. Second thing, the symptoms can be, you may feel the pain in chest, okay, and back, arms or legs. It's all because the defective hemoglobin what you have, HbS, the defective hemoglobin, okay, it, okay, is not able to carry oxygen properly to the tissues. So this defective hemoglobin is not able to carry the oxygen to the various parts of the body, because the shape of the cell is basically crescent shaped, and crescent shaped cell is not able to move through the blood vessels, and because of that there will be a deficiency of oxygen in various cells, and because of the deficiency of oxygen in the body you will be prone to the frequent infections, you will feel pain in the different parts of the body, and another thing is that your hands will swell, because the swelling will be because those crescent shaped blood RBCs will accumulate in the blood vessels, and they won't be able to carry the oxygen properly to the different cells. So swelling of hands can happen and feet. Anemia, obviously when your normal RBC becomes, round shaped RBC becomes crescent shaped RBC, then obviously the actual function of the RBC has basically changed, okay, and even you have seen also in the normal hemoglobin there was a glutamic amino acid that was replaced by the valine. Shape of cell has become from round to crescent, okay. Glutamic acid from normal hemoglobin was replaced by valine. So your actual the defective hemoglobin will be having valine amino acid, but normal hemoglobin has glutamic amino acid, okay. Your normal hemoglobin will give round shape to the RBC, but your defective hemoglobin will give crescent shape to the RBC. Because of that crescent shape in the RBC, it won't be able to move properly through the blood vessels. So it may either accumulate in the blood vessels, like it will stuck inside the blood vessels, okay. So my dear friends, that will also decrease our RBC count. When the RBC becomes from round to crescent, obviously the RBC count will decrease, okay. And blood clots can be also formed, as you know that normal RBC becomes crescent shaped, and that will lead to the formation of blood clots, okay. I hope you have understood this particular thing. May God bless you. Have a great time. Yo. Thank you.